All right, in statistics today, we're looking at the normal distribution versus the standard normal distribution. Okay, now, when you look at normal, what is normal? Well, suppose we're looking at a basketball team. And suppose this basketball team, on average, they score 70 points. All right, so it makes this a little curve. It looks like this. This is called a bell curve, normal bell curve. But what makes this normal about it is this. Right here, this is our average, which I said is 70. And most games, you see, it's the highest. Most games, they score 70. Now, they might score 71 or 72 a few times. And heck, they may be even over here. Say this is 75, say this is 80. They might score 80 every now and then. And then, of course, going back this way, here's maybe 60 right here. Okay, but most times they're around 70. This is the normal bell curve, because what is normal about it is usually above average, like 80, they'll score 80 just as many times as they will 60. So that's what makes the height here the same as the height there. Now, sometimes you might have one that's maybe skewed, like this right here is skewed to the left. Okay, you can see because it has a tail over here. This is skewed left. And of course, you could have one that's the opposite, that's skewed right, like this. And he's got a tail over here to the right. But most times, things follow the normal bell curve, where you have your average down the center, and then you have these numbers over here. Now, sometimes you might have this. Suppose you got another team, and they also average 70. Okay, but their curve might be like this. But you can see it's more spread out than that. This is 70, and this is 80, and over here is 60, okay? And so they're all over the place. It's more spread out because they might score 80 a bunch of times, and they might score 60 a bunch of times. And so what this means is the standard deviation is bigger than that one. So like on this right here, I would say right here at 75, that means my standard deviation on this one, I'll just write here, my standard deviation would be 5. Going 5 over here this way and then 5 over that way. I would have these points here that's called inflection points. Well, let me talk about that just for a second. Inflection point, this point right here is the point where this curve right here is going down like this. But right here at this point, it's starting to go up. Okay, so right here, we have a parabola that's going down, sort of like a parabola. But right here, we've got a parabola that's going up. And right here, this is called the inflection point, where it changes from going down to starting to go up. And that's where our standard deviation is. That's one standard deviation over, which here I'm just saying is 75. So my standard deviation is 5. Whereas on this one, okay, if I look for the point, it's more like right here where it starts curving down and then it starts curving up. And so if this is my average right here, that means my standard deviation here is 10. And so the bigger your standard deviation, the bigger it's going to be stretched out. And that's what our normal bell curves are. Okay, now we have what's called the standard normal bell curve. And this is a standard normal distribution right here. Okay, when we have standard normal distribution, there's only one type of this. Now, back to these, you can have all kinds of them. Heck, you could have one like this right here, like maybe a team scores only 60 points. That's their average. Okay, you might have something like that. They're all different. So you can have all kinds of normal bell curves, all kinds of normal ones. But now a standard normal bell curve, there's only one of them. There's only one standard bell curve. And right down the center is my average, which is 0. And then one standard deviation over here. This is one standard deviation, then 2 standard deviations, and then 3 standard deviations. Then we have -1 standard deviation, -2, and -3. And that gives us this normal bell curve. And 68% of our scores, like if we're looking at basketball games, 68% of our scores are going to be right here. You say, well, but that's 0. How do they score 0? See, that's the thing. We have to convert this. We have to convert to a standard normal distribution. So what I do is I'll take this normal distribution I have and I'll convert it to this. And how do I do that? Well, I convert it by using this formula right here and convert them into z-scores. So this is called my z-score. Okay. X is the normal score, and then of course this is the mean, and this of course is my standard deviation. And you just do X minus the mean, and then divide that by the standard deviation, and that converts to a z-score. Now, what do we do with the z-score? Okay, so we've got this table. Okay, this is called a z-score table. And if you notice, this says standard normal distribution. Table values represent area to the left of the z-score. So what that means is you have a standard normal distribution, and so like whatever this z-score is, that tells you the area to the left of that value. So like suppose this z-score here, suppose that's like 1 point, well it's not, let's say it's 1.2, okay? All right, so we look up this z-score. Now if you look at this table, okay, let me explain this table to you. Here's my z-scores down the side. So if I want to figure out what the area is to the left of this, I just go down until I get to 1.2. So you see these are all negatives, and then here's the second page. The second page has all the positives. And I just go to 1.2, which is right there, and that's 0.8849. Okay, now let's say this. Suppose our z-score here was 1.27. Okay, all right, so then I just go down here to 1.2, which is right there, and then I go over to 7, which is right there. So 1.27 would be this number right here, 0.89796. That's 1.27, and that's how you read these numbers in here. It's like these are your percents. So what that means is on this right here, what's it? 1.27. I done forgot that number. 0.89796. 9796. All right, that's the probability of all this that's colored in. Okay, so that means at this point right here, that's 89% of your scores of your games, whatever. 89%. Okay, now, what if I have the same thing? Okay, and I got this score. Let's say we got this score right here, and this is negative 0.72. Let's just say that's that. Okay, what's the area over here to the right? How much is higher than that? What percent do we have that's higher than that z-score? So what z-scores are higher than that? What percent? Okay, now, so what I do there is I got negative 0.72. I look it up on the table, but on this table now, this is to the left. So what I do, I look this up, and that tells me what's to the left. So what I would do is I would subtract that from 1. So in other words, when I look that up, that's going to tell me what the area is over here on this side. Okay, well I don't want this area, I want this area. So that means I do 1 minus whatever that value is. So if I look this up, negative 0.72, all right, here's negative 0.7 right here, and I go to 2, 1 2's right here. So this is my area, 0.23576. So this is here, 0.23576. That's what this area is, but I don't want that. I want this part over here to the right. So I just simply go 1 minus that, which gives me 0.76424, and that's what the area is over here on the left. because all the area under this curve is 1. That might be something I didn't tell you exactly on this. The total area underneath this curve is 1. You can see the percents here, 34, 34, 13.59. If I add all them up, it adds up to 1. And that's what my total area is under there. So when I find a z-score, if I want what's to the right here, well then I do 1 minus whatever that would be to the left. So see, I want this in the black. I figure out what the red is, and I do 1 minus that. Okay, now let's do this one. Suppose this is our normal bell curve here, and we don't have to have the bell curve, but suppose I want to figure out how many games, what's the percent of my games that we score between like maybe 73 and 82. Suppose I want those. Okay, so I look up the z-scores. Let's just say, now I'm just making this up. Let's just say this z-score is 1.16, which is the 73, and then the 82 right here, let's say that z-score is 1.84. Okay, so what I do is I look up both of these scores, 1.16, 1.84. So I look up these scores. All right, so 1.16, all right, here's 1.1. So I go over to 6, so 0, 1, 2, 3, 4, 5, 6 is this one right here, 0.87698. 0.87698. All right, now what's 1.84? So I go down here, 1.8 is right there. And I go 0, 1, 2, 3, 4 is right there, 96712. 0.96712. So I get these two z-scores, and since I want what's in between those, what percent do we have in between those? I just subtract these two. All right, so 12 minus 8 would be 4. There'd be 1. 6 minus 6 is 0. 16 minus 7, so that's what I get right there. So this is the percent that's between those two scores. Okay. Now we'll do some of these problems, and maybe that might help you understand a little bit better. All right, so let's look at this one right here. In a normal distribution, which is greater, the mean or the median? Okay, now I didn't tell you this, but in a normal distribution, the mean and the median are the same. They're exactly the same. So right here, neither. In a normal distribution, the mean and the median are equal. Okay, so in a normal distribution, the mean and the median are both the same. All right, number 2. What's the total area under the bell curve? I just told you that, 1. So that'd be C. The total area under the bell curve is always 1. Okay, number 3. Okay, what do inflection points on a normal distribution represent? Where do they occur? Okay, now, inflection point, like I told you, inflection point is where you got this curve that's going down and you got this curve that's going up. See? And the point where it stops going down and it starts on this curve going up, that's called the inflection point. So if you look at your bell curve, okay, here's my bell curve. It's kind of like right here, looks like, where it stops going down and now it's starting to curve up. That's called my inflection point. And it happens, like here's my average, here's my mu, and this goes over 1 standard deviation. So this is going to be mu plus the standard deviation. Of course, I have one over here too. That's going to be mu minus standard deviation. And so, let's see, right here, this is D. These are points where the curve changes between curving upward and curving downward. Okay, so see, like right here, this is curving upward, and now it starts curving downward. That's an inflection point, and here's an inflection point. Okay, where do they occur? Okay, it's going to be, let's see here, right here, D. It's going to be mu minus your standard deviation, and mu plus your standard deviation, which that's your mean minus your standard deviation, your mean plus your standard deviation. Okay. All right, number 4. It says draw 2 normal curves that have the same mean but different standard deviations. Describe the similarities and difference. All right, here's the thing. When we talked about this a second ago when I drew these right here, and see how this one, and it's kind of hard to tell my curves, but if I draw them on top of each other, if I just draw these on top of each other, this one's going to go like this, whereas the other one is going to do like this. This one gets taller because, see, this one, the standard deviation on this one is smaller, whereas on that one, the standard deviation is bigger. So since the standard deviation is bigger, it spreads it out, whereas when it's smaller, it makes it get taller and skinnier. Okay, so compare the 2 curves. The 2 curves will have, all right, it's going to have the same line of symmetry. The curve with the larger standard deviation will be more spread out than the curve with the smaller standard deviation. So what to remember, when the standard deviation is larger, it's going to be more spread out. Okay. Number 5. What requirements are necessary for a normal probability distribution to be a standard normal probability distribution? Okay, so to be standard, that means your mu has to be 0, your average is 0, and your standard deviation is 1. Okay, so that looks like D, the standard deviation, the mean and standard deviation of the values of mean is 0 and the standard deviation is 1. Okay, so that's D. Now, how can you transform a non-standard normal distribution to the standard normal distribution? All right, that's what I just showed you a while ago. Let me get my paper I had for that. Right here. This is how you do it. It's the z-score equals your score minus your mean divided by the standard deviation. So that looks like A, right there, first one. Okay. Number 7. Why is it correct to say a normal distribution and the standard normal distribution? All right, so as I showed you some normal distributions, there's several kinds of those, but there's only one standard normal distribution, with the mean being 0 and the standard deviation being 1. So I think here, my answer is C. The standard normal distribution is used to describe one specific normal distribution where the mean is 0 and the standard deviation is 1. A normal distribution is used to describe a normal distribution with any mean and standard deviation. Your mean could be anything, and your standard deviation could be anything. But in the normal, you got these 2 numbers. It has to be those. Okay, now number 8. If a z-score is 0, which of the following must be true? Okay, go back to my thing here. When you have a z-score, if you're going to get 0 z-score, that means these 2 are equal. I'll have x minus the mean. So like, say my x is 3 and my mean is 3. 3 minus 3 would give me 0. So that's the only way you can get 0, is that if x and mean and mu are the same. So things right here, the corresponding x value is equal to the mean, because the z-score is equal to the difference between the x value and the mean. So the answer is C. Okay. All right, determine whether this graph shown, see this graph here, could represent a variable with a normal distribution. Okay, this is not a normal distribution because we see this tail over here. We got, it's skewed left because my tails are to the left here. So this would not be a good standard deviation because it's skewed left. To be a standard deviation, it's symmetric, like this right here. Okay, so could not represent, no, it's not skewed to the right, crosses the x-axis. Right here, C. The graph could not represent a variable with normal distribution because the graph is skewed to the left. Okay. What about this one? Could this be a normal distribution? All right, now this one looks good. This one looks good. So the answer here is yes. The graph fulfills the properties of normal distribution. The mean is approximately, now what you're going to have to do to figure out the mean, okay, I just use this paper right here and just the very top right here, see, is my mean. And if I come down on that, it looks like maybe 18. Looks like right there at 18. There's 19 and 20. Looks like my mean is 18. And my standard deviation, now what I gotta look here is where does it stop curving down and start curving up? And it looks about like maybe right here, which would be like maybe 23 or maybe 22. I think it's 22, so that means 22 minus 18 is 4. That's what the answer says down here, 4. It's about 4. Now you just have to, try to estimate it a little bit, and it's kind of hard to tell mine because it's so small. On yours, I think you can blow it up on the screen and you can look at it a lot better. What about this one? Would this be a normal distribution? And on this one, this is a flat no. Now it does have a good symmetry to it, but the thing about it, see how it crosses the axis? We can't do this, it's a no. It cannot cross the axis. So looking at my answers here, could not represent, the graph is skewed to the right. Curve has 2 modes. Could not represent, curve is constant. Right here, it crosses the x-axis. See, we can't cross the x-axis, so that's a big no. Okay, what about this one? Could this be a normal? Yes, I think this one's okay. Because see, it's symmetric. It does not cross the axis. And if I get my little paper here, and right at the very top, okay, it looks like maybe 22. So my mean, the mean's approximately 22. I think it's yes, B. So the mean's 22. And the standard deviation, all right, now it looks like, let's see here. Like maybe right here, it stops going down and starts going up. So that's about 26. So if I do 26 minus 22, I get 4. And there's my standard deviation. It's about 4. Okay. All right, so here you go. Here's where we got to find some z-scores and stuff. So find the area of the shaded region. So suppose that this is to the left, and this says my z-score is 0.29. All right, so I'm going to look at my table. It's got a table here included. These are all the negatives. The positives are on the other side, so we got to do 0.29. All right, so I go down here, 0.2, which is right here, and then I go over to 9. So right 0.29 is right there, 6141, 0.6141, and we see our answer right there. So that's what this table is now. See this table, you see a picture here. Every number on the z-score table is the area to the left of that value. So all these are percents. Here's my z-scores out on the side with the top. And all these are the percents that's to the left of that z-score value. Okay? If you go to 0, if you look at 0 right here, see it's 0.5. Because right down the dead center is 0, and there's 0.5 that way and 0.5 this way. But to the left is 0.5. And that's what our z-score represents, the area to the left. Okay, let's look at some more of them. Okay. All right, find the area of the indicated region under the standard normal bell curve. All right, so here's negative 1.2 and here's 1.4. I want it between those. Okay, negative 1.2 and 1.4. So what I got to do is I got to look up both of these z-scores. All right, so let's look up negative 1.2 first. All right, so negative 1.20 is right here, 0985. Okay, see, negative 1.20. That means negative 1.20 right there, 0985. So this is 0985, 0.0985. Now let's look up 1.4. All right, it's on the positive page. All right, 1.4, 0.9192. See right there, 0.9192. So this is 0.9192. Now, since I'm between those two values, I need to subtract these two numbers. So I'm going to put 0.9192 subtract 0.0985. All right, so this is going to be 702. There you go, 0.8207. That's the area underneath this curve between those 2 points, which means to have these z-scores to be in between those, that's 82%. 82% are between those. So you can see all the area under the curve. You can see all this shaded. It's 82%. Whereas if I add 82 plus whatever that is and that is, that'd be a total 100%. But that's how you find the area between the two. You find each score, the percent of each score, and you subtract them. Okay, and what do we get? 0.8207? No, that's not what this answer said. It said, is this the right page? Oh, no, this is another problem. No, let's look at this again. Negative 1.2 is 0985. And then 1.4, 9192. And so I subtract them. Yeah, I don't know. I didn't get what they said here. 8041. I don't know, but I think we did it right. We'll go on. I'm going to stick with what we did because that's what the table shows us. All right, number 16. Find the area of the shaded region under the standard normal curve. If convenient, use technology to find the area. So, all right, I want between those two values. See, here's 0. Well, 0 automatically is 0.5 all of the time. Now, I got to look up negative 2.34. Negative 2.34. Okay, so negative 2.301. Oh, wait a minute, they got these out of order. That's what did they do this for? Okay, that's why we missed that problem, because these are 9, 8, 7, 6, 5. These are backwards. These are backwards. I didn't realize that on this. Okay, so let's go back to that previous problem. That's why the numbers are different. Okay, so negative 1.2, negative 1.2, 0 is this one right here, 1151. See, this is the 0, 0.1151. So this is 0.1151. Now 1.4 is on this page, and that's 0.9192. See, now this one went the right way, and the other one went backwards. So that don't make any sense. So that is 0.9192. So now 0.9192. So you better watch that, because it got me on it. It might get you. So 2 minus 1 is 1, 9 minus 5 is 4, 0, and then 8. So 0.8041, and that's what this says on here. So that was right. So you got to pay attention to your graph. This one, you can see the numbers go up, but for whatever reason, these numbers are going down. So you got to pay attention to that. Okay. So now back to 16 here. Find the area between 0 and negative 2.34. So let's look for negative 2.34. We already said 0 is 0.5. So negative 2.34. So negative 2.3 right here. And here's 4 right there. So that'd be this 0096. Okay, so you just look it up on the table. This is 0096. All right, so now I subtract those two. Oh, I'm sorry. This is 0096. That's 0.5, so I subtract. So 0.5 subtract 0.0096. Now I'm gonna have to put zeros here. This is gonna be 4. This is gonna be 0, 9, and this would be 4. There you go, 4904. So that's how much area we got here. And that's the probability between those two scores. And I think we're right. Okay. All right. Well, okay, this is number 17. I didn't see it there. Number 17, find the indicated area under the standard normal curve to the left of z equals 0.16. So 0.16, it says to the left, so that's what this does now. That's what this table does. It goes to the left. So all I got to do is look up 0.16. Well, here's the positives. 0.1, and here's 6 right here. So there we go, 5636. See, 0.1, 6. 0.16 is right there, 0.5636. So it's 0.5636. Okay, and we're right. Okay, to the left of this, 2.63. So to the left, that's what the table does. It goes to the left. So I go 2.63. All right, these are the negatives. Okay, 2.6. All right, here's 3 right here. So I'm going to come down this row here. 2.63 is right here. 9957. And there you go. You see that's right. 0.9957. Okay, number 19. To the right of this. Okay, now it says to the right. The graph, the table goes to the left. So since this says to the right, I look this value up, 0.58, and I subtract it from 1. Because see here, now look, let me tell you again. This graph, 0.58 is right here. All right, the table does this right here, but that's not what we're wanting. We're wanting to the right of that. So see, we're wanting all this part over here. That's what we want. So what I do is I find this, and then I do 1 minus whatever that is. Okay, so let's find 0.58. Actually, 0.58 would have been over here. But anyway, so I want to find this part. So 0.58, 0.5 is right here. And then 8 is here. So that looks like this number here, 0.7190. Okay, so that's how you look it up on the table. So this is 0.7, what did I say? 7190. That's the area to the left of that, but I want to the right. That's what the problem says, to the right. So I do 1 minus this, which is going to give us 0.2810. 2810. And there you go, we're good. Okay, number 20. Find indicated area to the right of this. It says to the right again. Okay, now again, let me show you on the graph here. Negative 1.68 is like right here. So this is negative 1.68. And the table here tells us what this area is to the left. Okay, that's not what we want. We want all this area over here to the right. This is what we want. So I find this z-score, whatever this z-score is, and then I'll do 1 minus whatever that is. Okay, so negative 1.68. Okay, here's negative 1.6 right here. And 8 is right here. Now see, this one goes backwards. You got to pay attention because it goes backwards sometimes on you. So we're looking at 0465. Okay, so this is 0465. So now do 1 minus that, which is going to be 0.9535. 0.9535. And there you go, 0.9535. Okay. Now one last one here, number 21. Draw A normal curve with a mean of 62 and a standard deviation of 15. Describe how you constructed the graph. All right, so since it has a mean of 62, then 62 should be down the middle. Like right here. See this right here? This is 62. It could be this one. And right here, it could be that one. And right here, it ain't this one because that's 77, so that one's out. Okay, so we know it's one of these two. Now, it says the standard deviation is 15. That means if I go 15 this way, if I add 15, I'm going to get 77. And if I go this way 15, subtract 15 from 62, that's going to be 47. I should have these values at my inflection points. So if I go to 77 and then 47, and I think this is what we got right here. See there? Yeah, see if you look at 77, it's about right here, and that's not the inflection point. It's still going down here. It's not starting to go up yet. So the answer would be B. Okay, so the let's see here. I select B right here. Okay. Now the normal distribution curve is centered at 62 and has two inflection points. Mu minus sigma would be the 47, and then 77 is mu plus sigma. Okay. Anyway, that's we're going to do some more of this, but here's just the opening round of it, normal distribution. This is like one of the biggest things in statistics. And if you need help, let me know. I'll try to help you all I can. Have a good rest of the day. Bye-bye.